All right, so we're going to do the AP Classroom for Chapter 8 here. This is probably going to be a long video, but it is what it is. So question 1. The environmental group wanted to estimate the portion of fresh produce sales identified as organic in a local grocery store. So in winter, we get this interval. We're going to need what the point estimate is. So we do 0.087 plus 0.133 and divide it by 2, and we're going to get 0.11. So that's this is our p hat for, what was it, winter? So 6 months later in the summer, the group obtained a second random sample of sales from the store. The second sample was the same size as the first, and the portion of sales identified was 0.4. How does 95% z-interval portion construct for summer sample compared to the winter? So 95%, this will be 1.96 p hat 1 minus p hat over n. Now n's the same on both of them. So for winter, it'd be 1.96, and we'd have 0.11 and what, 0.89 over n. And for summer, 1.96, that's not going to matter. And we'd have 0.4 and 0.6 over n. This number is going to be bigger than this. So that means we're going to have a wider one in the summer. So summer and the greater point estimate, yes, this is greater than this. So we could have gotten rid of this, this, and it's not the same for sure. It's wider and a greater point estimate. And the idea is the closer your p hat gets to 0.5, the wider your interval. It's pretty much as easy as that. Okay. Survey was conducted to determine the percentage of college students that would have chosen to attend a different college if they had known then what they know now. In a random sample of 100, 34% indicated that they would have attended a different college. A 90% confidence interval for all seniors who had attended a different college is, this is straight plug and play into the calculator. Now we're going to use 34. That's only because we're doing 34 out of 100. Half the time they give us a 0.34. Well, you have to go check that against the sample size because our calculator needs a whole number. So we're going to do menu. This is a one prop z interval. And we had 34 out of 100. And it's only because we had 100. And what did they say? They wanted a 90%. So we changed this to 0.9. And so we got 26 to 42%. There it is, 26.2 to 41.8. There you go. This is one we can probably do a lot of counting out here. So 32% own readers. Oops, sorry. So this number should appear here, which it does. It also should appear, these are out because the things have to be under the square roots. This is okay, this is okay, all those are okay, but then we just go to a 90%. Well, this is 99%, this is 95%. That's a 90%. Oops, sorry. Yeah, I mean, you can just do that by a process of elimination. You don't have to do much calculation there at all. Really, I mean, you could have started with 90%. You were down to this one, and this one, the standard error doesn't make any sense. It's not the right formula. 432 voters, 100 are in favor of certain bond issue, 95% interval. Well, the first thing to get rid of, those three. Those are not proportions. This needs to be a proportion, not a count. So A, B, and C are out, and we are talking about a 95%, which is 1.96, and that's all that's left, because that's out. It's got to be D. All right, question 5. Let's see. So when asked who the hero of the Olympics, 65% said they chose Blair. Poll of 650 adults done by a telephone had a margin of error of 4%, which the following statement best describes what is meant by the 4% margin of error. So what we're looking at here is, let's see, what about 4% were expected to change their minds? No, that has nothing to do with it. That doesn't even make sense. 4% of adults did not have telephones. No, that's not what margin of error doesn't cover any kind of bias like that. Same thing, this C would be some sort of bias. Not all 650 knew anything about the Olympics. Again, that's nothing there. The difference between the sample percentage, which is going to be 0.65, and the population percentage is likely less than 4. I mean, that's literally the definition of margin of error there. Okay. Commercial for breakfast cereal shown that certain television shown during a certain television program. The manufacturer of the cereal wants to estimate a % of television viewers who watch the program. If it wants to estimate, have a margin of error at most 0.02 at a 95% confidence interval, following which is the smallest super common question, right? So we want ME margin of error equals Z star P hat 1 minus P hat over N, and we're going to solve for N. Our margin of error, 0.02, 95% gives us our good old 1.96. P hat we don't know, so we're going to use 0.5, and we're going to solve for N. So we're doing all this in numsolve. We can do it here real quick. So menu, algebra, numerical solve, and so it would be 0.02 equals 1.96. Let me do this out of the way here real quick. Square root, divide 0.5 times 0.5 over N, comma N. 2401. I think we actually did that one in class too. It's like, doesn't matter if you want 2%. You don't know it, 2401. And we always go up, never down with a margin of error with a sample size, so E. For example, just for the record, if they had offered us, 2350, that would not have been the correct answer choice, even though that's closer to 2400. You want to go up. 2350 might put us outside the 2%, whereas 2500 will definitely get us inside that. All right, 7. Recent survey estimated 19% of people living in a certain region regularly use sunscreen when going outdoors. The margin of error was 1 percentage point. Based on the margin of error, which the following is appropriate conclusion. So good idea here. We got 19%, so plus or minus 1. So it's 0.19 plus or minus 0.01. So we're talking about 0.18 to 0.20 is our, well, that should be a 2 and not just a random line. So in this one, most of these answers just don't really make sense. Approximately 1% of people living in the region were surveyed. That's no. 18%, 20% of people living there were surveyed. No, this has nothing to do with that. All possible samples of the same size going 18%. No, it won't result in that. That's what, if we knew the confidence level, this is like the definition of confidence level, but that's not what we're talking about. The probability is that 0.0 is 0.01 that a person living in the region will use sunscreen. No, that's not it. It is plausible that the percent of all people who live in the region is 18.5. 18.5 is within our range, so it is plausible that that's true. Just like any other number in that range, but that's the only one of those that makes sense. All right. 90% confidence interval is created to estimate the proportion of television viewers in a certain area who favor moving the broadcast of the late weeknight news to an hour earlier than it is currently. Initially, the confidence interval will be created using a simple random sample of 9,000 viewers in the area. Assuming the sample proportion does not change, what would be the relationship between the width of the original confidence interval and the width of a 90% confidence interval was based on a sample of 1,000. We had one like this, right? You have P hat 1 minus P hat over N, so just compare them. P hat, which we don't know what it is, 1 minus, not going to really matter. over 1,000 versus p hat 1 minus p hat over 9,000, this one is going to be more narrow. It'd be less wide. People always want to say it's 1/9, but the thing is we're square rooting it, so it'd be 1/3. The second one, I'm sorry, the second confidence interval is actually going to be, the second confidence interval is 1,000. So this one is 3 times this one. This is the second, my bad, and this is the first. So this one should be 3 times as wide. The first one would be 1/3 as wide. Okay, that's just a wording of the thing there, my bad. Okay. Polling agency reported that 66% of adults living in the United States were satisfied with their health care plans. The estimate was taken from a random sample of 1,542 adults living in the United States. The 95% confidence interval was calculated as 0.636 to 0.684, which of the following is the correct interpretation of the 95%. Approximately 95% of random samples of the size will result in confidence interval that includes a proportion of all living adults. Nothing about probability. We don't like that. Will result in a confidence interval that includes proportional adults in the sample. We don't like in the sample. We want the true. Let's see what this one says. Of all random samples of living adults, it will indicate approximately 90% of all random samples of adults will living in the United States will indicate that between not 95% will not. We're not going to have the same one 95% of the time. 90% will result in a sample proportion. No. That means we get the same. Basically, D and E are actually like the same answer. So both of those are out. But B is basically our straight up definition of confidence level. Okay. Newspaper poll found that 52% of the respondents in a large random sample of likely voters in the district intend to vote for candidate Smith rather than the opponent. A 95% confidence interval for the population portion was computed to be 0.52 plus or minus 0.04. Based on the confidence interval, which of the following should the newspaper report to its readers? Smith will win because a majority of voters are in favor of Smith. No. So this tells us all plausible proportions are from 0.48 to 0.56. Now, the other thing about this is will win. That we're never going to say that. This is a poll of things, so it's like you never can predict. 95% chance that Smith will win doesn't make any sense at all. The poll predicts Smith will win, but there's a 5% chance prediction incorrect due to sampling error. No, that doesn't make sense either. With 95% confidence, there is convincing evidence that Smith will win. No, and the problem is we don't have anything. No prediction can be made, is what it says, because 0.5 is somewhere in here, so it's just as plausible to be below 0.5 as it is above 0.5. So we have no way of knowing that they're going to get more than 50% of the vote. If the whole thing was above 50.5 or the whole thing was below 0.5, we'd have some sort of prediction either way. But here, got nothing. Okay, this is a fairly straightforward one. They're going to throw some things at you that you don't need. In the campaign manager for a candidate for governor wants to estimate the difference between the percentage of voters who viewed an advertisement in favor of the candidate, percentage of voters who had not viewed the advertisement in favor of the candidate. 2 independent random samples of 500 voters were selected. One sample consists of voters who viewed the advertisement and 1 random sample consists of voters who had not viewed the advertisement. The table shows frequency of both. Which of the following is most appropriate for the campaign manager to use to estimate the difference between the percentages of voters who favor the candidate? What we're talking about, it says percentages. And wrong thing. So when you get to the AP test, here's where you've got to take it on yourself. Percentage implies proportions. I don't want to say means proportion because means something else. So we're definitely going to use a Z because zip. So the T's are out. Now here's the trick. Estimate the difference between percentage of voters in favor. So we have a difference means we're not doing a one sample. We're doing a two sample. And the trick here is we are never trying to estimate the difference between sample proportions. We're always trying to predict and estimate the difference in population proportions. We don't, estimating sample proportions doesn't do anything. That doesn't give us any information. Great, we are estimating. We don't have to estimate the difference in sample proportions. We have two samples that we can just literally subtract from each other. We're trying to estimate and forecast the difference in the actual population proportions. Okay. Here's another one we can probably do some elimination. Couple things right off the bat. We haven't gotten to these ones that look like this yet. I'm betting it's not going to be one of those. So we can start off with this, 95%. Out, out, out. And then we have two different random sample of 50 and random sample of 50 of brand S. So 40 and 1 and 35. So we should have 40 over 100, or 40 over 50 is 0.8. And 35 over 50 is 0.7, which, I mean, we could have just gotten that from any of these. These are all the same. These numbers have to repeat up here. And the only thing that's wrong with here is that. So this 0.75 and 0.25 mean nothing. We need 0.8 to be there and 0.7 to be there. So D. Most of these questions, when you have these formula ones, if you just know a little bit about the formulas and those numbers, you don't need anything else. All right, here we go. And it even tells us here, there's a whole bunch of stuff. Show all your work, blah, blah, blah. Polling agencies showed the following two statements in a random sample of 1,040 adults in the United States. Environment statement, protection of the environment should be given priority over economic growth. Economy statement, economic growth should be given priority over the protection of the environment. The order in which these statements were shown was randomly selected for each person in the sample. After reading the statements, each person was asked to choose a statement and it was most consistent with his or her opinion. Results are shown in the table. Okay, assume the conditions for inference have been met, which so means we don't even have to do the check part. We'll do it real quick just to show. Construct a 95% confidence interval for the proportion of all adults who would have chosen the economy statement. So this is all we're talking about. Now, we can just do that straight in the calculator. The problem is the first thing I need is 0.37 times 1048. Okay, and we can do that in the calculator real quick because I'm going to need that number. 0.37 times 1048. I get 387.76. So I'm going to use, what is it, I just already forgot mine, 387. So I'll use 388. Rounding one way or another is not going to make much of a difference, but I'll do that in the calculator. So we're doing 95% interval, and 1048 is my N. So menu, statistics, confidence intervals. We're doing a one prop Z. So we had 388 out of 1048, and they want 0.95. So I get 0.34 to 0.4. Looks good. There's my margin of error if I need it. So I'm going to write this down and just get 0.34 to 0.4. There's my interval. I've already got the answer. Now I just need to sort it all out. So we're going to do, I've already forgotten the first C. What thing we're going to do? We're doing one sample, one prop, Z interval for P, and I just go ahead and do it here, the true proportion of, does it say where this random sample, of adults, it did say economy, right? Okay, economy statement, of adults in the U.S. that would choose or have chosen, like you can, again, you can just use their words. would have chose the economy statement at 95%. Again, I'm going to go ahead and do the conditions. Random stated, 10%, 1048 is less than 10% of all adults. Can't do it there. In the U.S. Move this, sorry. My little thing here, you may not be able to see it. And it won't move. Why can't I move my thing here? Okay, we'll just deal with it. Okay. Normal. So 388 and whatever 1048 minus 388, 660 are both greater than 10. So there's our conditions. I know it says to assume, but I just wanted to show that. So calculate. Point estimate plus or minus margin of error. So we'd have point estimate is 0.37 plus or minus 95% gives us 1.96 times, I didn't need to do that, square root of 0.371 minus 0.37 over 1048. And that gives us our 0.34 to 0.4. Conclude, we are 95% confident that the interval from 0.34 to 0.4 captures the true, and I'm just going to say it, the true proportion of adults in the U.S. that would choose the economy statement. So that's part A. Part B, one of the conditions for inference met was that the number who choose the economy statement and the number who did not choose the economy statement are both greater than 10. Explain why this doesn't. This is the large counts condition. This shows that the sample size is sufficiently should be an L in there, large enough for the resulting sampling distribution, bad handwriting, sorry, to be approximately normal. Part C, suggestion was made to have use a two-sample z-interval with difference in proportions to investigate whether difference in proportions of adults who would have chosen the environment statement and adults in the United States who would have chosen the economy statement is statistically significant. It's two-sample z-interval for the difference in proportions, an appropriate procedure to investigate the difference. No, it is not. We would be required to have two independent random samples. Here we only have one. Simple as that. And two portions come from a single sample, so they're not independent. Anything like that's fine here. You have to have two independent samples here. And we don't. Okay, moving on. 14. A survey conducted by a national research sample of 920 teenagers in the United States. How often they use a video streaming service. Service. From the sample, 59% answer they use a video streaming service every day. I think that's incredibly low. 95% confidence portion of all teenagers in the United States who would respond they use a video service every day. So we need 0.59, we need this for our calculator. 920, we need that. So 0.59 times 920. 542.8. Did they say 95% they want here? Okay, so let's just go right to it. We need 543 is our number of successes. Menu statistics, we got a one prop again, one prop Z interval, and we got, I just lost it, 543. I have the memory of a goldfish. Confidence intervals, one prop Z interval, 543 out of 920. Keeping it 95%. And so there we go. 56% to 62%. One second, sorry. Okay, so we're going to choose, right? There was the C I couldn't remember earlier. Choose. I just like putting this all in one sentence. One prop Z interval for P, the true proportion of, let's see if they say, of all teenagers in the United States who would respond that they use a video streaming service every day. I'll write this out once, but you need to write it out twice. Teenagers in the U.S. who would respond. This is how they get out of it. They don't say that use a video streaming service every day. They would respond to this survey and say they use a video streaming service every day. Respond that they use a video streaming service every day. Okay. Check the conditions. Random, stated. Random sample, stated. 10%. 920 is less than 10% of all U.S. teenagers. And normal. So we had what? We just used it in the calculator. $542 at least. Normal, 542 and 920 minus 542 and 378 are both greater than or equal to 10. So there's our conditions. Calculate. Why didn't I even write it down? That would have been smart on my part. 0.56 to 0.62. Okay. Let's back up just to have it. 0.56 to 0.62. Was that right? I've already forgotten. Again, goldfish. 0.62, 0.56 to 0.62. So there's our interval. I should have written that down. Calculate. Point estimate plus or minus margin of error. So point estimate was 0.59 plus or minus, and we're 95%, so 1.96. Square root 0.59, 1 minus 0.59 over 920. And we get 0.56, 0.62. Conclude, we are 95% confident the interval from 0.56 to 0.62 captures the true proportion of all U.S. teenagers in the U.S. who would respond that they use a video streaming service every day. You have to write that. I'm getting out of it here just because I'm out of space and want to make this, I've already got a 30-minute video and trying to make it as short as I can. But you need to write that whole thing out. You can't just point to it. Okay, part B. Based on the accomplishment of part 1, did the sample data provide convincing statistical evidence that the proportion of all teenagers who would respond they use a video streaming service every day is not 0.5? Okay. 1 second, sorry. All right, sorry about that. So our entire interval, the interval from 0.56 to 0.62 contains the plausible proportions 0.50 is outside of the interval, therefore is not plausible. We have convincing evidence the true proportion is not 0.5. We actually have evidence that it's higher than 0.5, which our whole thing is above 0.5. But they're just asking if it's not. There's one of those ones, don't try to talk yourself into these things. All you'll do is lose points. Just answer their question. They're saying, is it not 0.5? Yes, we have evidence it is not 0.5. Okay, let's do one more confidence interval. Okay. Company makes 3 grades of a particular electrical component. Historically, grade A components have a 2% defective rate. Grade B have a component percent of 5% defective rate. And grade C have 10% defective rate. Since grade A is less likely to be defective, the company can charge more money for these components than it can for charge for B or C. Similarly, the company can charge more money for B than it can charge for C. Recently, the company found a batch of components warehouse that were known to be the same grade, but the grade was not labeled on the components. To determine the grade, the company selected from the batch a random sample of 200 components, which contained 16 defective parts. Okay, construct a 95% confidence interval for the portion of defective components in the batch. So here we go again. Choose one prop Z interval, or Zinterval, as the kids say, for P, the true proportion of defective components in the batch. Of defective components in the batch. And you can put that 95%. Don't really care about that, but just in case they want it. All right. Check. Random is stated in the problem. Where does it say here? Random sample of 200 components. Here's one of those ones where they don't do it to us. We're going to assume 200 is less than 10% of components in the batch. And then normal, we should have done this right from the beginning, shouldn't we? And they found 16 defective. So 16 and then 200 minus 16 is 184, are both greater than 10, greater than or equal to 10. So it's normal. Now let's go ahead and do that, because this one doesn't even make us find that. We got 16. This one's nice and easy. So we got 16 out of 200, and we're doing 95% again. Nice and convenient. Statistics, confidence intervals. We're doing a one prop again. No two props on this one. So we got 16 out of 200, 95%. So we got 4% to 12%. Let's write that down. 0.04 to 0.12. Okay. So now we do calculate. Calculate. Can't spell. I'm a math teacher. All right. So we do point estimate plus or minus margin of error. So we get point estimate is 16 out of 200, so that's 8%. Plus or minus 95% gives us 1.96 again. 0.08 times 1 minus 0.08 over our sample size of 200, and we get 0.04 to 0.12. Conclude. We are 95% confident that the interval from, oops, don't need the parentheses, 0.04 to 0.12 captures, I'm going to write the whole thing this time, make you wait. It's a short one anyway. The true proportion of defective components in the batch. Okay, part B. Does the interval calculated in part A allow the company to clearly determine the grade of component that was produced in the batch? Explain. So we have our interval 0.04 to 0.12 is all plausible portions of defective parts. So what A has 2%, so it is likely not grade A, as 0.02 is not in the interval. But 0.05 and 0.10 but it could be either grade B or C as both 0.05 and 0.10 are plausible proportions so no, they can't clearly determine oops, I don't know why I just put a G. Determine which grade the batch is, but they can determine it is likely, and you can say likely part A or grade A or likely B or C. Likely grade B or C. Something like that. You can't clearly do it, but you can rule out one of them. Okay, just under 45 minutes. Gonna have to feel good about that one. All right, there you go. Good luck.